Welcome back to Bad Attitude C10. In our last video, we went over our onboard air system for the guys over at K&R Performance Engineering, and today we're going to touch base on the launch controller. I don't know if y'all have ever seen one of these or not, but it's basically a single acting cylinder, and it is adjustable, and you can actually adjust at what RPM the car will launch at. So let's get to it. Alright guys and girls, what we're looking at here is the K&R Performance Engineering Pro Stage throttle actuator with remote solenoid. Now, when I started running the Enderle Top Hat mechanical injected motors, one of the things that we got away from was an electronic two-step, so we had no more stutter box to bang in, popping, throwing flames out the exhaust, which for me was a major plus because I liked having the ability to hold a certain RPM at a steady throttle without all the banging and popping, and when you release the trans brake, it just went from the set RPM for launch to wide open throttle and you were gone. So if you're like me and don't like hearing things like this, or this, or this, this launch controller might suit your needs. Now I already have the onboard air system to cover our CO2 or compressed air needs to do the launch controller and the dome pressure for the wastegate of the turbo, and I figured I'd go ahead and utilize it on the Bad Attitude C10. So let's go ahead and break down how this system operates. So the pneumatic cylinder we'll be using for our application is actually an adjustable stroke single action with one inlet, which will also double as a return whenever the air pressure is dropped off when utilizing the line lock, trans brake, or momentary switch. On the opposite end, you'll see a vent hole, which will allow air to escape when the cylinder is being pressurized, and it'll also allow air in whenever the cylinder depressurizes, so it doesn't create like a vacuum and not allow the piston to move. The next component will actually be the threaded rod. This will allow us to change the stroke of our pneumatic cylinder. In addition to that, there is a gray rod that will exit the opposite end of the barrel that allows it to be hooked up to your throttle linkage or your cable. So guys, please bear with me. I know my voice is a little scratchy and itchy. I'm getting over a sinus infection that I caught right at the start of building or putting this video together. So I'm a little better now, at least you can understand me. Now, the drawing, again, this is something I created on my own using the Photoshop program, so it's not exactly 100% scale. So the rod will give us a little over 1.5 inches of adjustment on our piston travel itself. So if you notice the threaded rod, if you screw it out on the top, it's going to actually allow free piston travel of about 2.5 inches. So let's say at that point you have, with the cylinder depressurized, about 2.5 inches of stroke, and it puts you at 2,500 RPM as far as the rod movement going outward when you go full throttle. Now, whenever you actually let the air on, the rod's going to suck in and it's going to be solid again, so you would go to full throttle whenever you let off. Now, if you look at the illustration below it, you notice that the adjustable rod is now screwed almost all the way in. So now the piston is basically set in the center, and it's showing that we have 1.25 inches of travel in our rod. So we've, instead of adding 2.5 inches of slack into our throttle, we're only adding 1.25 inches. So if the 2.5 yielded us like the 2,500 RPM, now we took 1 inch away. Let's say our max RPM that we're going to see with 1.5 inches of slack might be like 3,500. And the more that we take out as far as the slack means the higher RPM level you'll be at when it's initiated and you dump the pressure out of the cylinder. So just remember, guys, if you think about that old adage, lefty loosey, righty tighty, just think if you loosen it up, you actually are lowering what RPM by adding more slack. So if we back the jam nut out by going to the left, we're increasing the amount of travel we have, which reduces our set RPM to launch on. So if you tighten it up by going to the right, you're removing the amount of slack that you're adding, which means whenever you release the air pressure on your two-step or line lock, it's actually going to hold at a higher RPM. Now, another thing I want y'all to realize is even though we have 1.25 inches of the rod already sticking out of the cylinder, since the jam rod side is further in and the actual rod is out, the overall length from end to end is still going to remain the same, which is right at 10.5 inches. I'll show y'all this in a minute with the actual launch controller itself and a ruler. So in the next illustration, it'll actually show you how the complete system will work. Now, we all realize that we do have the pneumatic cylinder, which will be our launch controller itself. In addition, we'll have an air source, whether it be a CO2 tank, an air compressor, or whatever. Then we will have the control valve. Now, when the control valve is basically de-energized and there's no power at it, it's at rest, we're going to have pressure go out of our supply, whether it be a tank or a CO2 bottle, through the valve and goes into the inlet of the cylinder, which will pressurize it and make it solid. At this point, the piston is going to be up against the jam nut and the launch controller will be a solid piece of our linkage, just like it's not even there. So if you depress your gas pedal, it's going to function just like if you had a standard cable or a hard rod throttle linkage. Now, if you notice the one port on the power valve in the off position is the vent, it shows that it's closed. That's because we have the system shut, the piston's pressurized, the cylinder's pressurized, and our linkage is solid. Now, in the next phase, if we were to energize our valve and push either our line lock button, the trans brake button, the momentary switch, however you have it set up, could be even on a clutch pedal if it's a stick car, the air supply source is going to be blocked and that port will be closed. So we now are dropping the pressure. So in the lower picture, if you look at it, the cylinder will depressurize at this point. The piston can move freely. So at this point, if you were to floor the car, the slack that we initially set our RPM at comes into play. So the pressure would actually go out of the cylinder, backwards through the valve, and then out of the vent to atmosphere. So now we actually open the vent port on the valve to deplete the pressure that was in our cylinder. So at this point, the RPM that we are set at, whether it be the 2500 with the 2.5 inches of rod or the 1.25 inch sitting at 3500, that's what we would see. And as soon as we let off the button, the pressure would come back on and we're back to a solid linkage. So now I'm going to show you the actual components that came in our kit. So here is exactly what comes in our Pro Stage kit directly from K&R Performance Engineering. As you can see here, this is the Pro Stage launch controller, and I'm just going to go ahead and dig this stuff out and then we'll go through it real quick. It's pretty straightforward and simple, guys. So they do include some instructions, and again, guys, if there's something that you don't understand, you can always go on their website and get the instructions on your computer, or feel free to call Kevin and them up. Now, we get the smaller size line that would actually go from our control valve to the actuator or the cylinder, and our valve looks like this. And as you can see, there's a little vent on it. It's got a swivel 360-degree inlet and outlets are on here. It's pretty much just a 3-line, or it's 2 lines and then 1 vent and then 2 wires. And this little adjuster right here, you can actually adjust how quick it releases or applies. Alright guys, so now when it comes to the actuator or the cylinder, whichever one you want to call it, as you can see, it also has a 360-degree swivel, and that's for your air inlet. And then on the other side, this is the vent hole I was talking about earlier. I'm going to pull this out so you can see it a little bit. The hole will be open. There you go. And on the end that I'm moving right now, that's the actual rod that has a piston, and the black collar is 1/4 that you can hook up to a rod linkage or a cable, whichever you would like. Now, as I mentioned earlier, guys, this stroke on this, or travel, is right at 2.5 inches. And I was going to use this instead of a tape measure because the numbers are a little bigger, so bear with me. It's kind of a pain in the butt because it's actually a yardstick, so it's long. But anyway, so there you go. We're right at 2.5 inches long when it comes to the stroke. The overall length of the jam nut or jam rod is a little over 1.5 inches. So we have about 1.5 inches of adjustment we can actually take out of the stroke and move it to where our RPM can be increased or decreased to what we want to leave the line at. So I'm gonna go ahead and back this jam nut down real quick and then we'll move forward. So with the jam nut backed off of the rod, it actually comes out to about 1 5/8 inches of adjustment that we'll have. So we'll be able to change that 2.5 inch stroke and, basically subtract up to 1 5/8 inches from it. One other little cool thing to note, K&R does include with the actuator is this little bitty throttle ball stud with a quick disconnect. So you can just basically pull the collar down and pull the ball straight out. So I'm going to show this again because I think I might have been a little high on the camera. So just pull it down and pop it out. The overall length of this is actually 10.5 inches. So when it is compressed and the air is on, and the piston is hitting the jam nut wherever the position may be, it is right at 10.5 inches. So right here we got it to where it's set up for the 2.5 inches of travel, and as you can see, it goes from the 10.5 inch mark to 13 inches. So you add the 2.5 to the 10.5, that's what you get. Now if we screw this rod in, which is what I'm going to do right here, we're going to take it and screw it in 1 inch, and I'm going to time lapse this real quick, and then we'll come back and see where we're at. So as you can see here, we have now removed 1 inch of the stroke, so it's actually sticking out 1 inch. And I'm going to put the ruler back here again, well, if I don't drop it, and show y'all with it compressed and pushed all the way in, and it won't go in any further, it is still 10.5 inches. Now don't let the left hand measurement fool you because it's at an angle, so it's kind of misleading. But so with the end lined up, now you look here, it's right at 12 inches. So a minute ago it was 10.5 plus the 2.5 was 13. Now, whenever it was down, it was at 10.5, and we have 1.5 inches of travel. So now the overall length is 12. So we eliminated a full inch of the stroke from the cylinder. So I'm going to go ahead and change this up, and we're going to go another probably about 1/2 inch and see what happens there. Okay, so here we go again. So now we have 1.5 inches of the stroke outside of the bore. So we've actually changed our 2.5 inch stroke, and we've removed 1.5 inches, so that means we should only have 1 inch of travel. So our overall measurement, again, 10.5 inches. So now, since we removed 1.5 inches from the stroke, it is at 11.5. So exactly 1 inch of stroke now. So we went from a 10.5 to a 13 down to a 10.5 and an 11.5. So that gave us 1.5 inches difference in the throw overall. And that's how we would adjust our launch control. So thanks for watching, guys, and until next time, I'll catch you later.